This is the 0 stage. This is just recap part actually. These are coefficients k 0, both the coefficients are same, one is the conjugate of the other, isn't it? K 0 star. This is your E1 Fn, this is your E1 Bn dot 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 in general dot dot dot. This is your EPFN, EPBN, KP, KP star, where KP is delta P by sigma P square, because both the forward and backward prediction errors have the same variance we have seen. Okay, so I am not writing sigma P F square or sigma P B square, no point. I told you last time that I will drop that index F for a superscript A for B, where delta P was inner product between EPFN, EP. These are all standard stuff. I mean, what we have discussed. Sigma P square is norm square of any of the two. Okay. So, once the multiplier coefficients, which are also called K's, are also called reflection coefficients. Kp is the pth stage reflection coefficient. Once these are known, you can always construct the lattice and go on filtering it Xn. You really get the prediction errors for various orders for both forward and backward. But before that, you have to obtain these multipliers and all that. What will be given is the statistics of the process, in the sense the, of course, Xn is 0 mean. So, you will be given only the correlation, autocorrelation function, or at least many values of the autocorrelation function for, I mean, many values means autocorrelation function for many lagged values. Out of using that only you have to construct these. Okay. Then for sigma P square, you have found out this also, that was the recursion, the sigma P plus square was minus delta P square mod delta P square divided by sigma P square, right. This is I guess this is the one we derived, isn't it. But then that time I told you, and of course, how to start the recursion. Sigma 0 square is nothing but E of mod x n square, because E p 0 f n is x n. So, therefore, it is E p 0 a for E p 0 b n both are x n. So, just norm square of that means variance of that. Okay, but how about delta p? There is a question, because you can go into the recursion provided you also know delta p, you can update delta p, because sigma p plus 1 depend not only on sigma p, it depends on delta p also. So, I have to update delta p also from delta p to delta p plus 1, then only recursion can proceed. So, that is what we will be doing now. Okay. Now, I define this. So long we have been discussing the prediction errors. Also, remember, we have been doing, I mean, this prediction and all that, but what is the utility of the lattice and all that still has not come. We have got a structure. What is the purpose of this structure and all? It will evolve. Okay, as we study its properties and all, I mean, its utility in various fronts will evolve actually. Okay. Now, so long we have been discussing, we have been handling only the prediction errors or projection errors. For a while, I will now be considering not the error, but the projection only. Okay. That is x n, earlier I projected x n on the space span by x n minus 1 to x n minus p to the error. Now, I will not take the error for a while, I will just take the projection to, I mean, for a while. So, that means I will be considering things like this, p 1 p not perpendicular, p 1 p x n. Getting the error is very simple, just subtract it from x n, isn't it. This will be nothing but a linear combination of those elements x n minus 1 to x n minus p. So, the linear combination will be like this, I 1 to p. There will be coefficients. For some reason, I will introduce a minus sign with those coefficients. That's okay. I mean, I just put a minus sign also. And coefficients will be called, will be denoted by a. a subscript will be I, but also it is a pth order prediction. Suppose instead of p I do a kth order prediction, I will get new set of coefficients, isn't it? So, that is why I am giving two subscripts p comma I. Okay. These are also, I mean, you see, these are independent of n. Left hand side is function of n. You can say that how about n? N goes simply because of our logic of stationarity. Remember that these are nothing but optimal filter coefficients after all. When you give x n as desired response and x n minus 1 sequence as the input, obviously the filter coefficients will be given by these combiner coefficients because of stationarity. You know their exact values also, but I will not go for that calculation by R inverse p and all that here. Okay, I will be recursively updating them. So, they are independent of n. Similarly, this is for the forward projection. For the backward projection, we had p 0, p minus 1 and x n minus p was projected. X n minus p was projected on the space spanned by its p future terms. P future terms starting at n minus 0, that is n, x n, x n minus 1 up to x n minus p plus 1. So, that projection, instead of the projection error, again I am taking the projection, that again will be a linear combination of those elements which are spanning the space. So, introduce j, the range I will write later. Suppose you write n minus j. So, obviously, j has to go from 0 to p minus 1. A minus sign again I put deliberately. Coefficients I denote by b, but I will just to conform to the notation of the thing that is used. What I will do, first index will be of course p because it is a pth order prediction. Instead of having second index as j, I will call it p minus j. That is, I am just naming this way. When j equal to 0, that is x n, this should be called b p p. When j equal to 1, x n minus 1, this should be called b p p minus 1. Unlike here, a p 1 for x n minus 1, a p 2 x n minus 2, a p 3 x n minus 3. Okay. Here, the person I am projecting is n minus p, but I am not taking the coefficient with n minus p plus 1, that is the immediate neighbor, as b p comma 1. I am taking that to be b p comma 1 in fact. You understood the philosophy? X n projected on space spanned by x n minus 1, n minus 2 up to n minus p, the nearest one n minus 1, put the index 1 for that, next one put the index 2 for that. Similarly, n minus p. So, when it is n minus p plus 1, that is when j equal to p minus 1 here, that time I want 1 to be here. When it is p minus 2, that time I want 2 to be here. Okay. It is just a notation, let us say p minus j. Suppose these are known, for pth stage they are known, then obviously delta p. What is delta p? Delta p you have seen already, but delta p can also be written as I have been doing this again and again. What is EP? You understand how it comes? Okay, for those who have forgotten, for them I am saying, I am writing here, delta p is nothing but, if you can write this EPFN as p 1 p perpendicular x n, and this is as p 1 p perpendicular x, isn't it? I have been doing it again, and then I will just drop this logic. You all know, several times I have explained, and then again you call it EPFN. So, that is what I have done here, and EPFN is what? X n minus the projection. What is EPFN? X n minus this quantity, x n minus this quantity, this you write here, x n, and then it becomes plus, that is why I put a minus here. X n minus this and minus plus, comma and what is inner product? Inner product is correlation. So, what you can do? You take out each term, take the correlation of each term. Okay, forgot to take off my mobile. Take the correlation, and what will you get in the first term? Xn into Xn minus p plus 1. That means what? In terms of correlation, what is it? This is inner product. Inner product means what? E of Xn into X star n minus p plus 1. There is a difference in inner product. There is correlation. What is the lag? P plus 1. Okay, and then other ones. API remain as it is. This and this. This will be Rxx. What? N minus I x n minus I into x star n minus p minus 1. So you know the lag. That will be p plus 1 minus I. Okay. So if you know these coefficients APIs, and if you know all the correlation values of the process Xn, then you can find out delta p. So that is how delta p is to be computed. Mind you, there is no fast algorithm, recursive way of updating delta p directly. Recursive way means efficient, computationally efficient. Here you see so much of computation is required, and as the value of p increases, because you go for higher stage, number of operations in this becomes more and more. But this is something you have to be, you can't help. There are ways to parallelize this computation and all, that I will not go into by Schur algorithm and all. Okay, but you understand this computation have, depends on p, and this we have to carry out. Sigma p square could be updated recursively very simply. We don't have to really carry out sigma p square computation elaborately and explicitly in all terms and all. Just recursively can be updated. Delta p cannot be. But for that I need these coefficients. Not only the correlation values, which my assumption is that the correlation values are given to you, but I need these coefficients. So these coefficients need to be then again updated or at least computed. These coefficients can be updated recursively. Sometimes instead of projection error, we need the projection coefficients, because I need the filter coefficients in fact. So these are those coefficients. So that time I will be those values which I will be updating for various orders, that will be very useful. Okay. So what I will be doing? I will be updating this AP and BPs. You will see, because BPs also will be required. In updating of APs, BPs also will be required, and therefore BP also have to be updated. That we will see. So I will be only updating this AP coefficient and BP coefficients. But for any stage when APIs are known, correlations are known, for that stage I will find out delta p by this elaborate computation. So delta p known, sigma p known, then you go for sigma p plus 1 square for the next stage. This is how to go about. Okay. So APs will be order updated recursively, so will be sigma p square. Delta p has to be computed elaborately. No order updating, no fast technique for delta p. Okay. Now APs. Suppose I know this API and BP p minus j, these coefficients for pth order or up to pth order. Then I have to find them out for p plus 1th order. That is the way we are updating. Okay. For the time being, you assume that p for that is greater than equal to 1, because after all p 0 has no meaning here. Na? I equal to 1 to 0, what is the meaning? Or j equal to 0 to minus 1, there is no meaning if you put p equal to 0. So p equal to at least 1 or more. That p equal to 0 case we will take care separately. That is already you have been given the coefficients at the end of first stage. That is, you have found out at least p 1 comma 1 xn, p 0 comma 0 this, okay, xn minus 1. You know these coefficients, or p can be anything. For even 1, it can be anything, any number higher than 1. This is given to you, we are assuming. Then for any, if it is given up to pth order, we will update it. That is, we will find out same for p plus 1th order. And therefore, you can go on computing it. This is called order updating recursively. And for what happens at p equal to 0, we will find out. From that, we will obtain recursively for p equal to 1, then recursion for p equal to 2. So it will go on recursively. So you will evaluate it. But recursion will mean a lot of computational saving and all that. Okay, very nice. Now, how to do that? I want to find out the same coefficients for p plus 1th order, that is minus a p plus 1 comma I. That is, I want to find out these fellows. X n, that is by that formula, the notation, I mean that notation, it will be p plus 1 comma I will be 1 to p plus 1 now. I want to find out these coefficients using the given ones and other parameters Kp and whatever is available with me up to Ps stage. The way to go about again, is some beautiful linear algebra. That is, this projection is again nothing but what? Is the projection is what? It is a projection on the space spanned by x n minus 1 to x n minus p minus 1, p plus 1, x n minus p. That is W. What is the space? W1 to p plus 1. That is the space spanned by what? X n minus 1 dot 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 up to x n minus p minus 1. That we know is nothing but W1 comma p orthogonal span of n minus 1 . Isn't it? Last term is x n minus p minus 1. This I have been doing for last 2-3 days. What is the last term? X n minus p minus 1. So, take this out separately. N minus 1 minus p. Call n minus 1 as n prime. So, n prime minus p. Project that on the this space. That is same as projection error and take the error. So, that projection error is nothing but pth order backward projection error standing at index n prime, and n prime again is n minus 1. This is do you remember this, or do you have to go into it? Huh? That I am dropping. That is implicit. If you want, I can put a perpendicular, but that is implicit now. I am not bothered about, I am never going to do anything with ordinary direction decomposition. That does not help me at all. This is orthogonal decomposition. So, obviously, overall projection on this as needed here is nothing but projection here plus projection here. This projection I already know in this form. Projection on this is what? P1 comma P x n, that we already know. So, that I substitute there. Sorry. Okay, that is this fellow. And what is the other one? I have to take the projection between x n and this guy. What is that projection we have seen? X n with this divided by norm square of this into this, and x n with this turned out to be what? We have already done it in the case of lattice. It is nothing but inner product between EPFN and EPB n minus 1. This is nothing new. How did I get that projection error, that lattice equations? First I found out the projection and then subtracted. While subtracted, x n minus this part gave rise to the pth order, that is the previous order projection error, but this component remains same, plus became minus, isn't it? Just in case you have forgotten, x n with this means what? I mean, a projection on this means what? In case you have forgotten, sorry, into this guy, and EPB n minus 1 means P1 P perpendicular x n minus P minus 1. So, x n I can bring this operator here, repeat the operator here, and that is becomes EPFN. EPFN with this, that is delta P divided by sigma P square, whole thing I give name as Kp, reflection coefficient. So, Kp times this fellow, and what is this fellow? This fellow is error, isn't it? Error means x n minus p minus 1, this is the original one, minus the error. That error was what? in this expression instead of n minus p, it will be n minus p minus 1. What is, okay, for your sake, what is E p b n minus 1? That is nothing but x n minus p minus 1 minus the projection. Okay, let me do step by step. What projection? We are projecting this guy on what? The space spanned by p future terms. They start at n minus 1. You can take n minus 1 to the index n prime, current index. So, p future terms. So, that start at n minus 1, go up to n minus p. So, p 1 comma p, p 1 comma p, this guy. Okay. Now, I told you these coefficients do not depend on time, whether it is n minus p or m or k or l, whatever, they do not depend on time. So, if I call n minus 1 as n prime, if I call n minus 1 as n prime, then it is again p 0 comma p minus 1, isn't it? That is, I am projecting x n prime minus p on the space spanned by x n prime minus 1, n prime minus 2, dot 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 n prime minus p plus 1, isn't it? Same as this, only thing n replaced by n prime. So, I will have the same thing, n replaced by n prime. Okay. Same thing I am replacing this summation this minus will come x n prime minus j, is it n prime minus n prime is n minus 1. Okay. This I want to be in this form. Okay. This I want to write in this form. So, here what are the terms involved? You see, please see the terms involved, x n minus 1 to x n minus p minus 1, p plus 1 terms are involved. What are the terms? X n minus 1, x n minus 2 in this summation, x n minus 3 up to x n minus p minus 1. This I am writing like this. Here also I have those terms only, x n minus 1, n minus 2 up to n minus p, but n minus p minus 1 term comes out of this, and in this summation again see n minus 1, n minus 2 up to n minus p. So, n minus 1 to n minus p here and here, and n minus p minus 1 here. So, I just rearrange the terms and then equate the coefficients. Okay. How can I equate coefficients? Suppose I have say ax plus by equal to cx plus dy, x and y are variables, and I say equate the coefficients from both sides, a is c, b is d. What is the mathematics behind it? No, even what unique representation? Yes, if x and y are linearly independent, then only it is possible, mind you, because then you will take this to the right hand side, a minus c times x plus good b minus d times y equal to 0. The only solution is a minus c is 0, which is equal to c, and this b equal to d. Often you do this, matching coefficients from equating coefficients left hand side and right side. Essential thing is the independence. Without knowing also, people are taught in school like that. And all my samples are independent. All x n, x n minus 1, x n minus p, all samples are linearly independent. And therefore, I can equate the coefficients. It's just, you understand, huh? There is a term n minus 1. From here also there will be a term, sorry, where is that page gone? Yeah. There is a term n minus 1, n minus 1. From here also I can find out a term n minus 1. Take the two coefficients, add them, equate with the corresponding coefficient. Same you go on doing. So, from lower order pth order coefficients and from Kp you get the p plus 1th order coefficient. That is the philosophy. Okay. There is a higher order projection is written as a summation of two lower order projection and error. Error again you write as the original minus the projection. So, you can get back those coefficients, lower order coefficients, combine them and equate the terms from both sides, because all the terms are, there is term means samples, they are linearly independent. This is the philosophy. Okay. So, now if you want, I can do elaborately, find out x n minus 1 from both sides, what are the coefficient equate, find out x n minus 2 that way, but maybe we can do it in a compact way. You can just, because this does nothing but, I mean, rewriting terms, there is nothing conceptual here, just some notational jugglery and nothing else. Philosophy I have told you, I will be equating terms, same terms from both sides and match the coefficients. X n minus 1 from the left hand side, x n minus from the right hand side, what are the coefficients, equate them. Same for x n minus 2, same for x n minus 3, like that. This is the philosophy, but instead of doing in that schoolboy like manner, I will be doing it totally here. Remember, here and here I have got the same terms, n minus 1 to n minus 1 to x n minus p. This fellow is separate. So, obviously, minus a p plus 1 comma p plus 1, that is equal to k p, because only then you have got n minus p minus 1 when I equal to p plus 1, and that is the only term having x n minus p minus 1 in the right hand side. So, obviously, that particular coefficient is easily detected, minus a p plus 1 comma p plus 1 is same as k p. I will be writing separately. Okay. I want to put the two summation into one fold of summation. There is one with I and j, I want to have one summation. So, obviously, you see I have to do some trick, because here the range is from 1 to p, here 0 to p minus 1. So, I have to replace j by j prime or whatever, I will bring back I here also. Achha, this minus should not be there, because there was a minus and minus that became plus already. This minus should not be there. Original minus the error. Error was having minus sign. That minus and this minus, they became plus. So, I am sorry, this minus should not be there. And you can take out this minus out. So, something. What is this term? I will write later, but this I want to write as say n minus I. That means when I equal to 1, that corresponds to j equal to 0, and j equal to 0 means it should be b p comma p. So, that means b p comma p minus I plus 1. Is that correct? This is to be correct, right? Plus k p times this fellow. Then from this I will match the two. K p? Oh, there is a k p. I am very sorry. There is a k p. Thank you very much. K p is missing. This k p into this here. Yeah, otherwise there is no meaning. K p has to be there. So, obviously, you can write down the coefficients, that is a p plus 1 comma p plus 1 minus k p, and a p plus 1 comma I is this for I starts at 1. So, I greater than equal to 1, I greater than equal to 1, less than equal to p, up to p. When it is p plus 1, this is the formula. We started at the case where this p is at least 1, isn't it? And then you go for 2, that is p 1 comma 1 was given, p 1 comma 2, 1 comma 3. What happens that when p equal to 0, I am coming back to that later. And that is very simple actually. Or you want to see what it is? That is, consider p 1 1 x n, just manually instead of this recursive formula. What is p 1 1 x n? There is x n projected on x n minus 1 times x n. So, that gives you k 0, isn't it? X n inner product with x n minus 1 divided by norm square, by my notation that should be k 0. this lattice stage x n minus this is the error. So, this here is the projection, here is the projection. What is the projection? X n minus 1 times k 0. So, k 0 into x n minus 1. Okay. That means, okay, I will come to this little later. Let me complete this other, because I need both. Let me complete the recursion for B also. Let me complete the recursion. This was a recursion for A coefficient, that is p plus 1th order coefficient for A you obtain from them. But I have to do the same for B, na, because this needs both A and both B, A and B, pth order, lower order. From using the lower order values of A and B, I am getting the higher order value of A. So, I have to do the same for B also. Then again using them I can march towards p plus 2th order and so on and so, isn't it? The philosophy is absolutely same. Now, we will be doing it kind of routinely. That is, this is given to you. You have to find out P 0 P as this. This one P 0 P x n minus p minus 1. So, 0 to earlier it was p minus 1, now it is p minus b p plus 1 n minus j. Okay, this is what I will find out. This projection will be written as a linear combination of what terms? X n minus 0, x n minus 1 up to x n minus p, n minus 0 up to n minus p, right. In this form I want, but this projection is again what? What is the space here? Space here is W 0 p, which is nothing but orthogonal sum of W 0 p minus 1, and this is orthogonal sum. You understand that 0 to p means 0 to p minus 1, the last fellow. Last fellow is x n minus p. Or should I do this way? No, this is not the way. No, it is the other way. W 1 comma p, yeah, W 1 comma p, even I make mistakes. W 1 comma p, W 1 comma p, and take this 0 fellow, project on that W 1 comma p, take the error, that is E p f n. 0 to p, I am taking out the 0 k separately, 1 to p, and 0 means what? X n minus 0, that is projected on this, taking the error taken, that is this, isn't it? This I have been doing again and again. So, this you must become you must have become pretty conversant with this. 0 to p I am separating, 1 to p, 0 fellow I am taking out, projecting on 1 to p, taking the error, that is this. So, this projection is nothing but projection here and projection here. Projection here means, if you now call again n minus 1 as n prime, that means W 1 comma p nothing but, in terms of n prime, it is W 0 p minus 1. W 1 comma p means span by x n minus 1 to x n minus p. If you call n minus 1 as n prime, then x n prime up to n prime minus p plus 1, that is 0 to p. The trick there is, instead of n, I am calling it n prime, n minus 1 I am calling n prime. The moment you call it n prime, this becomes 0 to p minus 1. On that, if you project n prime minus p, that is what this formula is, with n replaced by n prime, isn't it? So, that I write here, simply produce that formula. coefficients do not change with substitution of n by n prime, that is moving from n to n minus 1 and all that. That is important, that whatever projection coefficients you got in this formula when it was index n minus p, same thing is valid when it is n minus 1 minus p. These coefficients do not change, they are independent of n. That is the key now. If it is time varying, non-stationary, then all these things crash simply, because these coefficients become varying with time, and then I cannot play this kind of thing, x, then what, n prime minus j, and n prime again I bring back n minus 1, so n minus j minus 1. So far so good for projection here, but there will be a projection on this. Projection on this means between these two, and between these two means what? Can you see? You are projecting this guy, yeah, but you are projecting for the rest of the community. Again, you are projecting this on this, fine. You are projecting this on this, means inner product between the two, norm divided by norm square of the two, and once again inner product between the two will give rise to delta p star. Why delta p star? Inner product between these two quantities, EPFN. What is EPFN? P1P xn. Pull that here. You repeat it here, and again n minus 1 is n prime. Immediately it becomes EPB n minus 1, isn't it? I am doing again. So this, even though is no need to think. I think these I have done possibly 7 or 8 times by now. This definition, what is EPB n minus 1, and this is your delta star p. So that means here you get Kp star. So this overall projection is projection here plus Kp star times this quantity, Kp star times this quantity, and this quantity is what? Original quantity minus, and there is a minus sign here with the coefficient, so it becomes plus. What is this quantity? Sorry, this is not EPFN, isn't it? Kp star into EPFN. EPFN means xn minus the projection, and within the projection coefficient there is a minus sign, so minus minus plus. This thing minus goes, it becomes plus. And again you put the coefficient, I varies from 1 to p. Now once again equate the coefficients. You see here you have how many what terms? N minus 1, because j is starting value is 0, n minus 1 up to n minus p. Here also n minus 1 to n minus p. These guys are the loner xn. N minus 1 to n minus p, n minus 1 to n minus p, only xn here. So combine these two, equate the terms from left and right same way. If I combine the terms, and my original thing was here, so I want to have summation of this kind of form, j equal to 0 to p, not this form. J equal to p means xn minus okay, j equal to 0 means xn, and minus b p plus 1 p plus 1, that is same as Kb star. So here actually I am bothered about j equal to 1 to p. So this form is required. So j or I does not matter, right, j equal to 1 to p minus something minus a p, instead of I call it just j, I equal to 1 to p API, j equal to 1 to p, so APJ. And from here what it will be? B p minus, see j equal to 0 means starting coefficient is p comma p with n minus 1, sorry, starting b j equal to 1, b, say j equal to p minus 1 you take on this side, j equal to p minus 1, that should happen at j equal to p. So, j equal to p minus 1 means p comma 1 and here n minus p. Yeah, p minus j, thank you very much, p minus j plus 1, and this kp thing will be there, kp star, and that lunar, that other fellow is here. Okay. So, I hope you can do this matching. I do not have to write those expressions separately. What is kp star, or I write for your sake? That means b p plus 1 p plus 1 when j equal to 0, that is minus kp star, and otherwise b p plus 1 comma p plus 1 minus j is that is for j in this range. Okay. All that is fine as long as p is 1, that is we start at p equal to 1 and go ahead. Okay. That is we are being given when p equal to 1, how many coefficients are, just consider the case p equal to 1. When p equal to 1, how many coefficients are there in the projection? Only 1, because x n projected on x n minus 1, so only 1. Okay. That coefficient you can evaluate directly, because that is kp only. If you see this p 1 comma 1 x n, by your notation that should be having only one term, x n minus 1 a 1 comma 1 p equal to 1 and 1. Okay. But what is this? By manual computation I know. What is this projection? X n projected on x n, x n minus 1. So, x n with x n minus 1 divided by norm square of x n minus 1 into x n minus 1. So, this is nothing but k 0, that means in the same way you will find out b 1 comma 1 is minus k 0 star. Okay. Now, see a beautiful thing of the lattice. I have given you the update relations fine. So, update recursions are over. Looking at the lattice, I want you to see this. The signal here, which also is a name E0 Bn, 0th order E0 Bn is same as Xn. Suppose I consider this term, this sequence E0 Bn, E1 Bn, E2 Bn up to EP Bn, say. It could have gone on with dot dot dot, but suppose I stop here. What are these? Which are available? Once the lattice filter is constructed, you are filtering, this prediction errors are available. What is the utility of this backward prediction errors? Now it will come. It is not only that they help in computing forward prediction errors. What are the utilities of these? Suppose I have got this space Xn. After all, if I want to do say Wiener optimal filter, we have done LMS algorithm and before that optimal filter, what we are doing then? We constructed a pth order filter. That was what? Projecting orthogonally what? Dn on the space spanned by xn, xn minus 1 dot 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 up to xn minus p. This is projecting orthogonally, that projection coefficients were the filter coefficients that we have seen. Suppose there you got pth order filter, I say that you get me the p plus 1th order filter. Again you have to compute nu R inverse p. From the pth order filter coefficients, you cannot get the filter, I mean p plus 1th order coefficient directly. But R inverse p formula and all that, you remember optimal filter, pth order filter you know, okay, orthogonal projection, these are the projection coefficients or filter coefficients, this is the formula R inverse P. Get me same for P plus 1, okay. Again another R inverse, another P, bigger size. That is what we had there. But my essential purpose is to compute the filter output, because that is the projection. Filter output is that projection. Now, suppose I consider these terms which you are on whose space, on whose span you are projecting x n minus 1, say x n minus 2 dot 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 say x n minus p. After all, you are considering the span of this, projected an external fellow d of n on the span, you are getting that projection as a linear combination, which is the filter output, right. That is what you are doing that time. You are taking the span of this, projecting d n onto the span, that output was coming as filter output as a linear combination of these terms. Those combiner coefficients are filter coefficients. But suppose from this I find out an orthogonal basis like this. I take x n as it is. You can make it orthonormal by taking the norm and divide by normal, you forget. I project this guy on this orthogonally and take the error. That means what I am doing geometrically, this is x n. Obviously, x n minus 1 is not in x n, and I project it orthogonally here. So, the space spanned by these two is same as the space spanned by these two. But what is this projection? X n minus 1 projected on x n, space error, that will be this guy. What you are not understanding? N minus 1, x n minus 1. So, this I leave as it is, I call E 0 B n. This guy I project orthogonally on this and take the error. That error is turns out to be this E 1 B n. So, these two are spanning the same space as these two. Suppose you get another guy, you make this a bigger set. No, I am not interested in this projecting on such a small space. Another fellow has come. Let me expand the filter order. Earlier only two terms, now another term. So, fine. Space spanned by these three is what? What I will do now? I will now take this guy, project it orthogonally on the space spanned by these two, take the error. That error will be what? Second order E 2 B n, that is n minus 2 is the index where you are standing, looking at two future terms. That is now out of these two, suppose a vector has come like this. Okay, vector has come like this. Okay, outside. So, you are projecting it orthogonally on this space, taking these axes. So, this and this, they become a space, they become an orthogonal basis of the space spanned by these three. Okay. Dot 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 dot, and last one, this you project on the space spanned by these fellows, that will give you. So, this set is an orthogonal basis of the same space which is spanned by these fellows. But if I want to now take the projection of any external guy d of n, desired response d n on the space spanned by this fellow, that is same as projection on the space spanned by this fellow. These are orthogonal. Computing that projection is very simple. Project on this, project on this, project on this, project on this. Into where also you add. If you now want to add one more guy, x n minus p minus one more guy here, what you have to do? You simply have to take that, project it on the space spanned by this fellow, and take the error. That is why that will be E p plus 1 B n. Just one more stage. Add one more stage of the lattice, that will generate E p plus 1 B n. Project d n on that also. Add with the previous projection. So, you understand, I can do order recursive optimal filters. That is, now onwards it will be what? D p, if I call filter output, d n is the external one, pth order projection, pth order projection, and I am calling cap, cap is estimate, projection, estimate, they are same. This is nothing but these terms, a linear combination of these terms, I equal to say 0 to p d n with E I B n divided by sigma I square, sigma p I square into and recursively dp plus 1. Okay. So, here dn was orthogonally projected on the space spanned by this, means you have to take the individual projections and add, that is what this dn with any ith backward projection error ei bn inner product divided by the norm square variance into this. Okay. And if you know the pth order projection and you want to find out the p plus 1 order projection, is very simple. To this you have to add this extra term with the new fellow p plus 1 bn. Up to this was there, you are adding one extra chap here, just project it orthogonally on the space spanned by this, take the error, that error is this, you just compute this extra projection. So, you understand recursively it can be obtained. So, as you go from I stage, stage to stage, the sigma I square they are updated, mind you. Okay, they are updated. Only thing is this needs to be computed recursively, that I leave to you. It is very simple. You have already done one inner product updating. Delta p updating you have done or not. Instead of delta p, there are two projection errors. Now, one is dn, another is this. Philosophy will be same. Okay. So, that is all for today. Thank you very much.